Assalamualaikum warahmatullahi wabarakatuh and hi. We are from group 2 of EH2435C are going to present our group project which is well designed and completion of Belarus well wall. First of all, my name is Mohamad Azfar bin Jemain and my student number is 2019-415698. So, first of all, let's go to the introduction part. Multilateral wells technology has shown us several benefits in the development of oil and gas industries, such as increase to the production of hydrocarbon, generate significant saving, potentially increase profit, and also high flexibility of application in different types of reservoir which it may be applied. Based on the benefits stated above, the needs for drilling TAML level 5 stacked multi-branch had been identified by us in an oil field and also had been analysed in our research work. Technology advancement of multilateral TML consortium objective is to promote the advanced development and also installation of multilaterals within the international petroleum industries to dialogue, information and technology exchange and also collective sponsorship. Some of the TML members are Submerger, Chevron, Mobil and many more. In TML classification, multilaterals are divided into level of complexity from level 1 until level 6. There are three main characteristics that can be used to identify the multilateral technology, which are connectivity, solution, and also accessibility. For TML level 5, seal junction multilateral are necessary for reservoir management and also to handle complex geology in well environment with multiple pressures, fluid, and also the rock strata. In these cases, pressure integrity is a must to prevent junction collapse due to pressure drawdown. In this level of multilateral well, full hydraulic and also mechanical pressure integrity at junction is achieved with completion. Next, we go to well completion. Well completion is a series of activities to prepare a newly drilled well for the production of oil and gas or other purposes such as injection. The objectives of well completion are to provide communication between the reservoir and the well, optimize production and injection performance, ensure safety and also to maximize the integrity and reliability of completion over the completed well life and minimize the total cost per unit volume of fluid produced or injected such as the cost for maintaining production.
Bismillahirrahmanirrahim. My name is Mohamad Hafiz Hairulnizam. I'm from Group 2 for this Drilling Engineering Group Assignment presentation. So for my part is I will expand about case studies that cover the well design, which is we choose three. The first one is Troll Algae Field. The second is Ecuadorian oil field, and the last one is Dos Quadras field. Okay, those three case studies has their own issues that we can apply into our well design. At Troll Algae field, at this field, they apply the dual lateral well, which has less drainage ability that may affect their production rate and offers high pressure drawdown. When there is a high pressure drawdown, it will cause a conning issue and also will cost a lot of operation funds. So the project of ProAlgae, they apply the technology, a new technology, which is ITBSM, which is a TML level 5, and they apply also a trilateral stacked well that can lower the pressure drawdown and have a high drainage ability. For the second case study, Ecuadorian oil field. Uh, in this case study, they stated that the targeted reservoirs located beneath the rainforest area, which the horizontal well need to be built to reach the target. If they want to reach the target, they cannot use the vertical well method, where it can affect the rainforest ecosystem, and the production are not so economical. So they came up with a plan to apply dual lateral stacked multilateral well in improving of their production and lower the cost of operation. The third case studies, which is Dos Quadras field that located at the California, America. This is the old field that use single lateral horizontal well that are not really relevant because the operation cost is over the profits. So what they do, in solution, they apply trilateral stacked well to lower the cost and can reach the target that they never reached before. Okay, for the next slide. As you can see here, this is our spider plot that we determine that we decide to place the oil rig at the 25 to the west, to the east, and 125 to the north. So from this oil location, we link with the targeted reservoir which is T1, T2, and 3T, we got the horizontal distance quite long. But by placing the oil rig at the designated place, we can obtain the stacked multilateral method, which is more economic for our project and easier to install it. Okay, next slide. Okay, this is our well design by Microsoft Excel 2010 that we obtained from the calculation from the data given and from our assumption on build up rate, which is we apply 4 degree per 100 feet at all targeted reservoir. And also this is the result of our calculation. So as you can see, the first table is for T1, second is T2, third one is T3. Okay, next slide. Okay, this is the result or the design, the final design that we create by AutoCAD software. As you can see, the design of the figures is more detailed. As you can see, the parameters, we include the parameters and also we indicate where is the oil rig at the above. Not to forget that our oil rig is a jack-up rig, which is can adapt with the sea level above 50 feet. For our final design that we obtained from the calculation, we got the stacked trilateral well that apply the build and hold trajectory for easier to drill into the targeted well and more economic for the project. As you can see, based on our assumption on build up rate, we obtain the medium radius range curvature and we decide to place the KOP kickoff point at different depth to easier the engineer to allocate and to apply TML level 5. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Husseini bin Johan and I will present to you about the relevant assumption and justification in our multilateral well trajectory. Based on the given data, we firstly assume that Naga 2 rig, which is a jack-up rig that is suitable to use in 328 feet of water depth, located at Block SB2T in South China Sea, near to Sabah waters at the given coordinate. For the reservoir, we assume that the reservoir is unconsolidated and undersaturated reservoir. The flow along the well is uniform, consists of clean sand and mica sand. The formation pressure is 390 psi, permeability of 1 to 10 rasi and porosity of 30%. For the crude oil, we assume that have an API between 15 to 23 degree and viscosity of 40 poise. For improvement on stacked trilateral well, we have suggested to use an advanced method of steering well bore trajectory, which is using rotary drilling with downhole adjustable stabilizer. Adjustable stabilizer is a downhole steering mechanism to control borehole inclination while rotating the drill string. It is equipped with adjustable stabilizer blade that can radially expand to keep in contact with borehole to ease the construction of different BHA to build or drop angle. It can be controlled from the surface for easier handling. Next is using active reservoir management service to recognize reservoir performance uncertainty caused by the inability to define reservoir and flow mechanism adequately. The impact of the uncertainties can be reduced by maximizing reservoir performance through the use of integrated multidisciplinary technology in a methodical manner. Lastly, maximize the reservoir contact to well. It requires extensive modeling studies to optimize total length, placement, and configuration of branch to satisfy reservoir management strategy. As the result, well productivity can be improved, the unit cost of drilling and production can be reduced, and the limited drainage space available between wells and can be utilized.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Hariz Kamil Roslan and I will present about the well completion, which is technology advancement multi-lateral, also known as TAML. So first, the suitable level that we choose is level 5 because the first thing is it is because the formation is unconsolidated. So we need because of due to the unconsolidated formation, when the junction is made, the junction is weak. So we need the junction to be cemented and cased. Okay. So next is the level 5 can maintain both mechanical and pressure integrity, which means that with this level 5 completion, we can decide whether to do the validation whether independently or commingled. Sorry. And the last one is because near the junction, there is a water zone. So by using level 5, it ensures that there will be no produced water. So water from the water zone will not enter the production. So that's why we choose level 5 and not level 3, because level 3 at the lateral is only case, not cemented. So there's a probability that the water could come into the production and produce water. That's all.
So next we're going to talk about the well completion equipment. So for this well completion equipment, this is the well completion equipment that we already designed for this 3 well. So we assume there is a 3 zone for production zone. So we're going to talk from the bottom, and this is a Y line entry guide, and this is a no go nipples, and this Y line entry guide is to track back and guide the Y line tools from the bottom to go back into the tube, and this no go nipples is to seal off and the location of this perforation tube there above it, and this perforation tube is to collect the production fluid from this zone. And permanent packer, this is a permanent packer to isolate these two production zone so they don't commingle. So next, this is a locator seal assembly, and we also have landing nipples. So landing nipples have the same function as the no-go nipples, so they also seal the location of the equipment above them. Next, there's a blast joint in this zone. So why there's a blast joint is to strengthen and support the strength of the tubing, because as a production fluid go into the well, so the pressure will crumple the tube, so this blast joint will support and strengthen the tubing strength. And then this assembly is there's two flow coupling, and between them there's a slide sleeve door. Sliding sleeve door is to allow the production from the production fluid that come into the well to go into the tube via the slide sleeve door, and this flow coupling is to control the turbulent flow that will come into the slide sleeve door. And there's a hydraulic packer. Same, we need to isolate this between these two production zone. So there's a blast joint too to ensure to strengthen and support the strength of the tube from the pressure come into the well. So there's a hydraulic packer above this zone. Why we install hydraulic packers there is to prevent from the corrosion fluid production to leak off from the tubing. So same there for this assembly, same, there's a flow coupling, two flow coupling, and between the flow coupling there's a slide sleeve door here, same function as this. So this for above the hydraulic packer here, so there's a flow coupling, there's two flow coupling there, same function, is to control the turbulent flow around the tubing. And then this SVLN and SCSSV is to control the flow in case there's a failure at this Christmas tree and the wellhead. So here there's two line here. This is a tubing hanger. Tubing hanger is used to seal and isolate hydraulically between this annulus and tubing. So this is a Christmas tree and the wellhead. Same, in they are functioning to control the any hydraulic flow in this well and tubing.
Okay, now I will talk about the conclusion of this research study. As a conclusion, the production of rate of oil can be improved by the use of multilateral wells technology. The multilateral well will give huge impact on the productivity of the reservoir as well as the financial profit and also income. In well completion process, we can see that TML level 5 is the best TML for the well due to its formation and also the location of the study field, as it provides many advantages and also beneficial factor to the well. Next, the best type of multilateral well completion method for this well is open hole gravel packing. This is mainly due to the location of the study field and also the sand formation that we can see in the flow stream. Okay, that's all from us. Thank you and have a nice day.